Alrighty. Then let's continue. And today we're going to talk about, does anybody have a guess about what we're going to be talking about today? We're going to be talking about more graphing. What do we think we're going to be talking about today? We're going to be graphing what?
Tangent?
Yeah, but before we do that, let's first learn about cosecant and secant, and then we will learn about tangent and cotangent. All right, so our very first section, section one, is going to be talking about cosecant. And let's start with our most basic one, which is y equals cosecant of x. There's our parent function. What do we remember about cosecant? What is it actually equal to? This is what? Maybe
Um,
Helena, can you tell me? Or no, whoever, sorry.
the reciprocal of sine, so
Mhm.
hypotenuse over opposite.
Yeah, but the first thing you said is more important to what we're doing now. It is the reciprocal of sine, which we could just say cosecant x is 1 over sine of x. So if we're graphing it, we have to think it's probably going to be very similar to sine of x. And in fact, when we graph cosine of x, step one is to graph sine of x. So that's what we're going to do first. We're going to graph our sine of x. And we know that I'm going to label some things up here. We got +1, -1. And I'm going to label, since we know the period of sine is 2 pi, we have a pi over 2, a pi, a 3 pi over 2, and a 2 pi. All right, and then we know that sine starts at 0 and it goes up, down, down, up. And we just connect those dots, and that is our basic sine graph. Then what we need to do is we need to, so that's step one. Then step two is to oops, is to find our asymptotes for cosecant of x. What do I mean by asymptotes? Well, guess what? If sine is 0, if sine of x equals 0, what does that mean for cosecant? That's 1 divided by what? So let me write it maybe like this. If
Is it undefined because it's 1 divided by 0?
Yeah, but in the graphing world, anytime you have something undefined, it's actually either positive or negative infinity. That's what undefined means graphically. Anytime you divide by 0, what's actually happening is you are going towards infinity. And we can think about this very simply, right? If I have 1 divided by, let's look at a number right before 0. Like for example, 0. Well, let's look at just 0.1. Well, that's the same thing as 1 over 1/10, or just 10, right? Because if I divide by this fraction, I'm multiplying. If I add another 0 here, well, that's 1 over 100, and that's 100. If I add 3 or 4 more zeros here, guess what? We just add more zeros here. The closer you get to 0, what happens to that number? As this gets closer and closer to 0, I keep adding more and more zeros. What does it look like is happening to this number? It's getting what?
Bigger?
Yeah. So if I could reach, which we can't, but let's say we reached 0, well, guess what? That would equal infinity. That's the whole idea. That's why when you divide by 0, technically, it doesn't equal infinity. It approaches infinity. It gets closer and closer. So we just need to mark wherever sine of x equals 0, we're going to draw our asymptote. All right, and we know, well, right here it's 0. This is a 0, so right here it's 0. Right here it's 0. And then guess what? All we need to do now is step 3, graph cosecant of x. Or more importantly, graph 1 over sine of x. And all we need to ask ourselves is, well, what happens if I have, for example, what happens right here? Sine of x is 1. What's 1 divided by 1? Well, it's just +1. So that's going to be that point right here. Well, we know that this right here is maybe about 0.5. What's 1 divided by 0.5? That's 2. So right about here, maybe it's going to equal +2. And right here, it's going to equal maybe positive 3, and it's going to keep increasing. And guess what? It keeps increasing all the way to infinity. It's going to hit this asymptote. Over here, it's going to do the same thing. I like to memorize it like this. I draw a sine, and then whatever shape sine is, I draw an opposite. It's not a parabola, but if you draw a parabola, you'll be okay. It's steeper than a parabola. So the actual shape of this, and I'm going to graph it right here so we can actually see it. Let's graph sine of x. Then let's graph cosecant of x. And you can see it right there, but it's not a parabola. It's a little steeper than a parabola, but don't worry. All that matters is you have the general idea. As long as we label the asymptotes and we show that this is approaching those asymptotes, we're good. And then anywhere where we have sine is a down, like an upwards cup like this, we're going to draw a downwards cup like this. And guess what? It repeats forever. It's going to keep doing this over and over again, and that's cosecant. It follows sine. Everyone give me a thumbs up if this makes sense, what cosecant is. All right. So we need to get really good at graphing sine because guess what? To graph cosecant, you first have to graph sine. And it gets a little more complicated when we have a more complicated sine. Let's look at our first example. So our first example, let's do y equals cosecant of 4x plus pi over 2. All right, what's step one? Step one is we're going to graph what?
Sine of x.
Yeah, but not sine of x, sine of what? We're going to graph y equals sine of what?
Oh, 4x plus pi over 2.
Yep. You're going to graph, basically, you take whatever this is and just replace this with sine. Everything else stays the same. If there's a plus here, amplitude, right? Whatever it is, you do the exact same thing, but with sine. Because we're going to use that as our reference to figure out what happens next. All right, well, now we have to do all of our steps with sine. So we have to, what do we have to do first? So first we're going to, I'm going to just say isolate x, right? So we have to make x by itself. So to do that, we're actually going to take sine, and we're going to get what? Sine of what? What does this become?
4 times x
Hmm?
plus pi over 6.
Not pi
Or
over
pi over
6,
8.
pi over 8, perfect. But you're on the right track. Awesome. Yeah, you just take this number and we divide it by 4. And anytime you have this and you divide, if you're having trouble dividing with fractions, always just multiply by the reciprocal because this is so much easier to see that this is just pi over 8. So that's how I like to do it. But if it works for you, do whatever method works. I like to multiply by the reciprocal anytime I divide by fractions. That's just the easiest for me. All right. All right, what's our next step then? We need to find what? To graph sine. So we need to label some things. What's this guy and maybe what's that guy?
B and C.
B and C. Perfect. Let's do our first step. Find the start point. And the start point is where? At what? At C equals.
Negative pi over 8.
Perfect. And then we need to find our period. And what is our period equal to? Helena, how do I find the period for sine?
Um, do we have
Remember?
to do 2 pi divided
Hmm.
by um b?
Hmm. And what would that be here?
Um, wait, is that a 4? Oh,
Hmm.
so wait, I don't. Oh, is it pi over 2?
Yeah, 2 pi over 4, or that's just pi over 2. And this tells us our what? Our period. But what do we have to do next to figure out? Because this period tells us how many times, how far the distance is for sine to repeat, right? It tells us this distance because after this, guess what? Sine does the same thing. Oops, the same thing over and over and over again, right? These are the waves. So if you ever hear the word wave, the period is the length of each wave because it kind of looks like a bunch of waves, right? But we don't care about this. We want to figure out the distance between the points, right? The points of interest on our wave. And how do we find that? We take,
Um,
mhm.
oh, I was gonna say we divided by 4 again.
Yeah, or I like to just multiply by 1/4, but exactly the same. And what does that become?
Pi over 8.
Yep. So the distance between points is pi over 8. Now, don't worry that these might not always be the same. We did some examples last time where they're not. A lot of times they are the same because homework problems want you to be able to graph it so it doesn't look ugly. If you remember last time, I had to write like, oh, this was pi over 2 plus 2, and it's kind of ugly because it's hard to add pi and another number together. Don't worry too much about that. Um, you'll usually be given these will usually be the same, but do not assume that they're the same. That's not necessarily true. Okay. So I just want to make sure that we don't, oh, well, C is this. That's not always true. It just happens to be for this specific problem. All right. And now we can graph sine. Um, and we don't have any vertical shift and we don't have any asymptote. I mean, not asymptote, sorry, any amplitude. So we know that that just goes from positive to -1. And we're going to start where? Where's our starting point? Let's find that first. So maybe Isa, where am I going to start?
Um, is it uh
Well,
pi
we
over
know pi over 8, but not positive, but
negative pi over 8?
yeah. Oh, hold on. I think oh no, give me 1 second. All right, let's do this. This will be for you guys to graph. Please graph it while I wait for my iPad to just reconnect. Yeah, we're going to start at pi over 8 and then mark each of our points. So after pi over 8, where do we go next? So um, we have Helena. Where after pi over 8, can you tell me the next 4 points that I label? So we do negative pi over 8. What's the next point? What's the distance between points?
Um, is the next point pi over 4?
Not pi over 4. We
Oh,
have negative pi over 8, and we're adding what to it?
oh, pi over 8.
Yeah, so what does that become?
Is
What's the next point?
oh 0?
Yep, and then add another pi over 8. What's the next point?
Pi over 8.
Mm-hmm. And after positive pi over 8, what's the next point?
Pi over 4.
Uh-huh. And after pi over 4, what's the next point?
Um, I don't know.
Well, we had pi over 4, right? That's the same thing as 2 pi over 8. What's 2 pi over 8 plus one more pi over 8?
Oh, 3 pi over 8.
Perfect. And if you want to do one more after that, it would be pi over 2, which you can get from adding one more pi over 8, which gives you 4 pi over 8. And 4 divided by 8 is 2. All right. Once we do that, give me 1 sec. My iPad's almost connected. After we do that, we're going to graph sine. Sine goes up, down, down, up. And if you want to continue it a little bit more, you can. Um, and then yeah, Masha, that looks perfect. Yeah, if everyone wants to know what the next step is, it's to graph our asymptotes. And um, maybe Isa, can you tell me how do we know where our asymptotes go? And this is for cosecant. Once we draw sine, which you just did, how do we find cosecant? What is the next step to graph cosecant? We need to find our asymptotes. How do we find those? Where is that?
Is that where where the lines hit 0?
Where what hits 0?
Um, the
Wait, you said the lines or did you say something else?
it's like where the the dots
Where,
hit.
yeah, and the dots would be where sine hits 0. Does that make sense? But yeah, anywhere where the dots hit 0, you're going to draw a vertical line. And then all you're going to do is you're going to find the peak, each peak, and you can look at Masha's for now while my iPad is loading, because that is correct. And you find each peak of our sine graph. You have a positive, like where it's +1 and where it's -1, and this will repeat, obviously. And that's where you're going to draw. It's not a parabola, but it looks a lot like a parabola, but it's kind of this big cup shape. And it's going to approach infinity on each side. Give me 1 second. See if I can get my iPad to load. But yeah, any questions on this before we do another example? Oh, all right, let's go all the way to section. Here we go. So I'll zoom through this a bit, but right here, oops, connecting pencil. There we go. So right here, we're gonna have negative pi over 8. Right here, we'll have pi over 8. We'll call this one oops, hold on 1 second. We'll call this one pi over 4. We'll call this one 3 pi over 8. And if we want to go again, pi over 2, right? And then to graph sine, starts at 0, goes up, goes down again, goes up. And then we can say maybe goes up again, right? And this is our sine graph. And it follows this kind of pattern, right? And it will repeat, and it'll keep repeating like that forever. Forever in that direction and forever in that direction. And then what we do, so once we do that, step 2 is to graph our asymptotes. And this is anywhere where y equals 0 on our sine graph, right? Anywhere where the dots are at 0. So right here is a 0, right here is a 0, right here, right here, right here, etc. forever. And then we just are going to draw, if there's a downwards cup, we're going to draw an upwards cup. Over here, there's an upwards cup. We're going to draw a downwards cup. And we're going to repeat this and make sure these touch. That's kind of important. So don't draw it as messy as me. All that really matters is that you have this point and the general shape and the asymptotes. They have to be in the right place. As long as you have this, this is your cosecant graph. And it repeats for as long as cosecant repeats. Any questions so far? Everyone give me a thumbs up if we are ready to move on. Perfect. And then Helena, does this make sense?
Yeah, makes sense.
Okay. Let's now move on to our next section. And guess what? This one's going to be secant. And secant is going to be exactly the same as we did with cosecant. The only difference is we're going to start with graphing cosine. So I'm going to go a little quicker through this one, but we're going to first graph cosine. And cosine, we know, goes again from +1 to -1. At 0, it's going to start here. We have a pi over 2, a pi, a 3 pi over 2, and a 2 pi. And we know that it goes down, down, up, up. This is the general shape of our cosine graph. And that's what it looks like. And our cosine graph, and in fact, let me maybe do a little bit further. I'm going to go here and here. I'm just going to graph a little bit more of this just so we can see the repeating pattern. The cosine graph is very, very similar. In fact, it's exactly the same. The only difference is our secant gets shifted a little bit. So the only difference is instead of having this upwards cup over here, it's just moved over here. And remember, that's because guess what? Cosine of x is sine of x if we add pi over 2. These are the same graph. So guess what? It's going to be, secant is going to be the exact same as cosecant, but if we move it, look, we moved it pi over 2 to the left. Instead of this dot being right here, it's over there now. So it's going to be the exact same process. You're going to graph cosine instead of sine, and then you're going to find the zeros, and then you're just going to draw the cups. Exactly the same. Nothing changes. Any questions on this? Everyone give me a thumbs up if the general idea makes sense. And we're going to do an example right after that. All right, does that make sense, Helena?
Yeah, it makes sense.
Okay. All right. All right, so first example, let's do y equals secant of 1/5 x plus pi over 5. And can someone tell me what am I going to do first? What is step 1?
Graph cosine of 1/5 x plus pi over 5.
All right. And then Isa, how do I do that? Let's call this step A now. Let's do a mini step. What is the first step of in order to graph this? What do I have to do first?
Uh, do wait. Do you like find A, B?
But can I just label this as B, this is C, and this is A, or is there something I have to do first?
Oh, uh, cancel out the I or like
Yeah, you're on the right track. You have to make X what?
oh, isolate X.
Yeah, or make it by itself. Whatever makes sense to you. You just have to factor out whatever's in front of the X. So we now have Y equals cosine of what? What number am I taking out here? Isa.
Um, 1/5.
Yeah, 1 over 5. So then this just becomes X. And what happens if I take out a 1 over 5?
You take it out on the other side.
Yeah, so if I factored out a 1/5 from here, what's left? If I divide this by 1 over 5, right?
Uh,
So I have pi over 5 and I divide it by 1 over 5. But remember, I like to do division of fractions by multiplication. So if I divide by 1 over 5, that's the same as multiplying by what?
multi by 5.
Yeah, and what happens to those guys?
It cancels out.
Yeah, so what are we left with? Say it one more time.
Is it pi?
Yeah, and this makes sense because if I multiply this by 1/5 and this by 1/5 and I distribute now, because remember, factoring is the opposite of distributing, right? This is distributing. If I want to do the opposite of it, I factor. That's what factoring means. And guess what? It's going to give me that. So I did the right thing. All right. What do I need to do next? Maybe Masha, can you tell me what is my next step?
Find the starting point and the period.
Yeah, so let's do that first. Where's my starting? So start point at C equals what?
Negative pi.
Perfect. And while we're at it, what is the period?
Um, is it 10 pi?
Well, it's going to be 2 pi divided by 1/5. And that's the same thing as multiplying by 5. So that's 10 pi. Perfect. All right. So I have my period. What do I do after I find my period? I have to do something to find the
Multiply
distance.
by 1/4.
Yep. And we could just say that that's 5 pi over 2, right? Because this is 10 pi over 4, which becomes 5 pi over 2. And that's the distance between points. All right, let's graph cosine now. And Helena, can you tell me where am I going to start? So what am I going to put for my first pick? I'm going to put a point where?
Um, oh, what's the first thing? Is it
Oh,
uh
1 second. My audio keeps. About that, say it one more time.
is it 5? Is it like
Remember, our starting point is from our phase shift,
oh
C. So what does
negative
C tell us?
pi?
Yeah, negative pi. So right here, I'm going to put a negative pi. Then I'm going to move. What's the distance between this to the next point is what? How do I go from here to the next point?
Um, add 5 pi over 2.
Exactly. So negative pi. And negative pi, we could say, is the same thing as 2 pi over 2 plus 5 pi over 2. What does that give me? What's that?
3 pi?
What?
3
Yeah,
pi
3
over
pi
2.
over 2. So we can call this one 3 pi over 2. All right. And then what happens if I add another 5 pi over 2 to that? What do I get? I'm gonna make these a little bit closer together. So let's add another 5 pi over 2 to this to get our next point. Where's this pick at?
Is it 4 pi?
Yeah, right. That would be 8 pi over 2, which is 4 pi. All right, and what happens if I add one more 5 pi over 2? And you can keep this as 8 pi over 2 to help you.
9
What
pi
does
over
that become?
2?
Not 9 pi over
Oh,
2.
um, 13 pi over 2.
Exactly. And this is good enough. You can keep going if you want. Your teacher might ask you to draw like, the first three periods, right? Or the first three cycles. But if they don't, this is the length of one cycle. Remember, this is only one period. This is one wave or one cycle. All those mean the same thing. If they tell you to graph one wave, one cycle, one period, that's what this is. All right. And we have what kind of graph? What kind of graph do we have? So, and of course, the amplitude we said goes from +1 to -1, right? So the last step, amplitude. All right, so where do we start? Right here at the start point. Isa, where am I going to put a dot?
Is it at 0?
When is 0?
Like
What kind of graph do we have?
cos um
Cosine always starts where?
is it at it oh sorry, is that +1?
Yep, cosine always starts at the top and it goes down, then it goes down again, then it goes up, and sorry, I meant to draw one, we're missing one more tick. Because this is not one full cycle. I apologize. We need one more tick, right? Because this is 1, 2, 3. We're missing 4. My bad. I accidentally counted 0, but this is not a point. This is the first point. So we need one more. We add one more 5 pi, and we get 18 or 9 pi. 18 pi over 2 or 9 pi. All right, and then it goes up one more time. And now this is one full period. You know it's a full period because guess what? We ended in the exact same place we started. And that's how you know that we've successfully drawn one full period of our cosine graph. I would draw a little bit more of your cosine graph. Why? Well, because guess what? We're not drawing cosine, we're drawing sine. Secant. And secant cares about these sections. Does that kind of make sense? So, for the sake of getting this a little more accurate, this is going to be 23 pi over 2, and that's just, right, this is 18 pi over 2 plus 5 pi over 2. And this one right here, right, remember this is -2 pi over 2, and we're going to subtract, right, a 5 pi over 2. So this is going to be 7 pi over 2, negative. Okay, so those are those points. Does this make sense so far? Everyone give me a thumbs up if we can graph this. All right. Then from there, oops, let me make sure that's actually plugged in. All right, then from there, what do we do next? What is our big step number 2? Graph what?
The asymptotes.
Exactly. And those asymptotes are going to be whenever our cosine graph is 0. So one's right here, one's right here, one's right here, and one's right here. And by the way, cosine and sine and all of these, they look more rounded like this. Try not to make them as triangular as this. It's really not going to matter for graphing. Like your teacher's not going to lose points, but um, to be a little more accurate, it should look a little more round. So I'll fix that. There we go. All right, and then from here, our last step is just to graph secant. And remember, all that is let's do it a different color. We're just graphing this guy. And we just need to make sure, let's make sure we're a little more accurate. We need to make sure it touches right here at that point. Same thing right here. And we need to make sure it follows the asymptotes. And as long as you do that, we are good. Although I keep missing. So let's put that right there. There we go. And this is our secant graph. Okay? Any questions on this? Everyone give me a thumbs up when we've got this and we're ready to move on. Take your time. All right. All right, let's now talk a little bit about, and then Helena, were you able to get this? Sorry.
Yeah.
Okay, perfect. All right, let's now talk about our next section. So, section 3, guess what? We're now moving on to tangent. All right, tangent is not related to sine or cosine. It is, but it's not directly related. It's not as easy as, oh, we're just going to a little bit different. We have to learn what this graph looks like. So let's do it the same way we did the other one. Let's set up a table and see what the X and Y values are just by plugging it in. And we have to remind ourselves, right, and this is for Y equals tangent of X. We have to remind ourselves our unit circle. And what I mean by that, right, is what happens at negative pi over 2. And remember, I don't know if we talked about it too much, but for tangent, we really care about like for example, sine, the basic sine graph starts at 0 and goes to 2 pi. Now, technically, it repeats everywhere, right? I could also have graphed it over here and only looked at this section, and it would still be one period of sine. Same thing over here, but we talk about the basic sine graph as going from 0 to 2 pi. Same thing with cosine. We talk about the basic cosine graph as going from 0 to 2 pi. We talk about the basic cosecant graph as the exact same, right, as sine, right? This is one period of the cosecant graph. For the secant graph, it actually goes from, look, it goes from negative pi over 2 all the way to 3 pi over 2. This is one period now. It doesn't matter too much. You don't have to memorize that. It just means that you have to extend your cosine graph a little bit. But now tangent, the basic period, starts at negative 90 degrees. And we'll talk about why in a second. We'll see when we start graphing it. And then, of course, the next one is going to be negative pi over 4 or negative 45 degrees. And then right here, we're going to have 0 or 0 degrees. Right here would be then 45 degrees and 90 degrees. But remember, we only care about radians, right? We're only graphing in radians, right? The actual x-axis is only going to use radians. All right, and then let's remind ourselves, all right, what happens at negative 2 pi over 2? Well, from our unit circle, from our table, we know that at pi over 2 or at 90 degrees, tangent is undefined. It's undefined. And I'm going to tell you that it's actually negative infinity. Okay? And we just have to remember it's negative infinity on this side. All right, well then right here, we know it's negative, oops, this one is now negative 1. That's what happens at pi over 4. We know it's positive 1, but negative pi over 4 is in the fourth quadrant where tangent is negative. All right, and then 0. Well, at 0, tangent is 0. At pi over 4, well, now it's positive 1. And at pi over 2, this is back to just our unit circle. This guy's undefined, and it's positive infinity. Okay, so this is our basic tangent table. And let's take a look at what this actually looks like graphed out. So we're going to graph, and I'm just going to mark some basic things. Let's mark our negative pi over 2. Let's mark our negative pi over 4. Let's mark our pi over 4 and our pi over 2. And guess what? Anywhere where we have these undefined areas, those are asymptotes. So we're going to graph our asymptotes first. Okay. And that's at pi over 2 and negative pi over 2. And then we're going to mark a couple points. We're going to mark, well, let's first mark our positive 1 and our negative 1. How do we get this? Well, that's just these guys. And we're going to mark, we know at 0, it's 0. At negative pi over 4, we're told it's negative 1. At positive pi over 4, our table tells us it's positive 1. And guess what? It just follows the asymptote after this. So it's going to look something like, now tangent looks a lot like, let me make this as nicely drawn as I can. It's going to look a lot like our what do we call it?
x cubed graph. It looks a lot like an x cubed graph, but this is what it looks like. And all you need to remember is to mark these points and to mark our asymptote. But guess what? This is one period. What does tangent actually look like? Well, it looks like this. And of course, why did we go from negative 2 pi to 2 pi? I mean, not negative 2 pi, sorry, negative pi over 2 to pi over 2. Well, because look, that's where the asymptotes are. And guess what? Over and over again. And let's graph it so that you can see a more accurate and slightly clearer drawing. So if we take a look at tangent of x, that's what it looks like. And if we look at x equals pi over 2 and x equals negative pi over 2, those are our two asymptotes. Okay, and this is what tangent is. This is how it repeats over and over again. But let's take a look at something. What is the period of tangent? It's not 2 pi anymore. What is the distance between these asymptotes? Somebody tell me, what is the period equal to?
Is it just pi?
Hold up one second. I was like, my audio did that again. Can you please say that one more time? I'm so sorry.
Pi over 2? Or just pi?
Just pi, yes. The distance from this point to this point. This is pi over 2, and this is pi over 2. And if you add those together, you get pi. So the period is pi. But remember, this is only for tangent. If we have a b, this would be divided by. And of course, what do I mean by a b? Well, tangent of, remember, x plus c, right, times b, right? We can still have a b, and we can also have an a, right? And a, what does a change? A changes these points. What does b change? B changes our period. What does c change? That's our starting point. And d just shifts our middle line. And anytime you shift the middle line, all you do is you just draw that new middle line and pretend that that's the x-axis. All right, well, that's our period. How do we find our asymptotes? So this is very important. This is not 2 pi over b. Tangent and cotangent have a different period. Now for sine, cosine, secant, and cosecant, this is the period. I mean, sorry, this is the period. But for tangent and cotangent, it's only pi over b. All right, and if we want to figure out our asymptotes, guess what? That's just plus and minus your period divided by 2. You take whatever this number is. For example, in this case, it was pi. So if you divide it by 2, you get negative pi over 2 and positive pi over 2. All right, any questions so far? Does this make sense? Just what this basic graph looks like? Everyone give me a thumbs up. Awesome, awesome. And then Helena, does that make sense?
Yeah.
Okay, let's now do a quick example. So let's do an example. We have, oops, I just lost that example. Which one we're gonna do? Let's do this one. Let's do y equals negative 2 tangent of 6x minus pi. All right, so this one's going to be a little bit tricky. So let's go through it together. Step 1, we need to take out the b, right? Isolate x, whatever you want to call that step. All right, so then y equals negative 2 tangent of, well, that's a 6. So I'm going to take out 6. And I'll be left with x. And if I take out 6 from here, I'm going to divide by 6. All right, so now I need to figure out what is the period, right? So there's step, let's call, well, this can all be in step 1, right? We want to find the period and we want to find the asymptotes. And our period is just equal to pi over b. And guess what? Here is our b. Here is our C, here is our A. All right, so pi over B is pi over 6. And guess what? If we want to find our asymptotes, well, that's just equal to plus and minus the period divided by 2, which is plus and minus pi over 6. And remember, I like to do my division like this. So divided by 2 is the same thing as multiplying by 1 over 2. All right, well, that's just plus and minus pi over 12. So there's my asymptotes. And now here's what we're going to do. Step 2 is to fill out our table. Okay? And our table is going to look exactly the same as it did before, right? So we have our X, our Y. We're going to look at, here's how the table works. It starts at negative asymptote, right? Whatever our asymptote is. And that's always going to be negative undefined or negative infinity, okay? Then after that, you get negative asymptote divided by 2. This is your next area. And this is always -1. Then 0 is 0. Asymptote divided by 2 is 1. Now this 0 is 0 is only works if you're not adding a d. If you add a d, well then all of these values get plus d. Does that make sense? We don't have a d in this problem, so I'm not going to talk about that, but that is what you do if we have a vertical shift, right? Because everything gets vertically shifted. All right, and then the last thing we care about is the asymptote, and that's going to be positive undefined or positive infinity. And let's draw some dividers in that. Okay, well, the next thing we have to do, step 3, is edit our table, right? We have to fill in the actual information based on what we found right here. So can someone tell me, what am I going to put for negative asymptote? What is the negative of our asymptote? What is that? Negative what?
Negative infinity.
What's the point though? What's the x point? We literally, whatever you found for asymptote right here, that's the first x point, which is what? What did we find for the asymptote?
Negative pi over 12.
Perfect, negative pi over 12, and that's always negative infinity, right? You don't have to worry about down here. Down here doesn't change. The only time down here changes is if we have a d. Up here is the only thing that can change. And that's really easy. We just need to take a look at our asymptotes, right? So that's the first step. Then what is negative asymptote divided by 2? Well, that's just negative pi over 24. And then that we know is going to be -1. Then 0 is 0. This is going to be positive pi over 24, and this is going to be positive pi over 12. And this is going to be, it's going to be +1, this is going to be positive infinity. All right, so that's the first step. We filled in our table. Okay.
Is to not edit our table. Let's call it fill in our table from the asymptote, right? From what we found for our asymptote. Now, guess what? Are we done here? No, because we're not starting at 0. We have to take into account our phase shift. So if we have a C, then step 4 exists, and step 4 is to edit our table. How do we edit our table? We just take our table that we made, and guess what? This point, we're going to add our C to it, because our C is our starting point. So we don't start here. We actually start at negative pi over 12 plus pi over 6. And then right here, it's negative pi over 24 plus pi over 6. Oops, pi over 6. And we keep doing this for all of our values. We add pi over 6 for all of them. So this one would be what was this? This is 0 plus pi over 6. That's just pi over 6. And this one is pi over 24 plus pi over 6.
Okay, so sorry for that. My computer died. So if you're rewatching the recording, let me just recap very quickly. Step 2, we fill in our table. So we're going to fill in our table. It's always this pattern. It's once you find the asymptote, it's negative asymptote divided by 2, 0, asymptote divided by 2, asymptote. And these are always the same. Then step 3, we edit our table if we have a C. What does that mean? You take this You take all the x values and add, I'll put it right here, you add your c. In this case, our c was pi over 6. So negative pi over 12 plus pi over 6, positive pi over 6. Same thing here, 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 and here. And we add all those. And then your very final step, we'll call this step 4, is multiply everything by a. And the only thing you actually have to multiply is these two. Because guess what? 0 multiplied by anything is 0, and any infinity multiplied by anything stays infinity. Except if you multiply this by a negative. I'm so sorry. Let me make a correction here. What happens if we take negative infinity multiplied by negative 2? It becomes positive infinity. And this one, I'm so sorry, becomes negative infinity. Why? Well, because guess what we're doing? We're taking our standard tangent graph. And what happens if we have a negative here? Does anyone remember from our regular transformations? What's that called? It's a something about the x-axis.
A translation?
Yeah, what kind of translation? It has a special name.
Wait, is it like the opposite?
It's a reflection about the x-axis. So if it's a reflection, that means it has to flip our regular tangent graph upside down. But don't worry too much about that. You don't have to worry about that because you'll realize that when you multiply everything by a, the infinity stays the same. I'm so sorry, but the negative sign flips. So infinity times negative 2 is negative infinity. So the 2 doesn't do anything to infinity, but the negative definitely does. And then from here, our last step is we're just going to label all of our points. So here's pi over 6. Here's 3 pi over 24. Here's pi over... Wait a second. This should not be pi over 6. This should be pi over 12. Positive pi over 12. Oops. That's what I meant to write before. That's what we did right when we were adding, but I don't know why I changed that. So let's fix that. That's pi over 12. This one's pi over 6. This one is 5 pi over 24. And this last one is 3 pi over 12. And then from here, we just mark all of our... So we're going to first mark our asymptotes. There's our 2 asymptotes. And then we're going to mark our positive 2 and negative 2. And then let's just label it. Right here, we have a positive 2. Right here, we have a 0. Right here, we have a negative 2. And guess what? We just follow our asymptotes for the rest of this graph. Oops. And this is our tangent graph. And this is our tangent of this. All right, does this make sense? Can everyone give me a thumbs up if we understand this? All right, and then Helena, does that make sense?
Yeah.
Okay. Super, super quickly, I want to show our very, very last one, which is section 4. We've got cotangent. And I'll do this very quickly. It's very similar. The only difference, so the steps are the same. The only difference is our table is different. Our table now is going to look like, x and y. It's now going to go from, so we have negative pi. Then we're going to have negative 3 pi over 4. Then we're going to have negative pi over 2. And then we're going to have negative pi over 4. Oops. And the last one is 0. And this one's a little different. It goes, it goes from, so I can draw that a little bit better. It goes from right here, we're going to have positive undefined, which is positive infinity. Right here, we're going to have positive 1, 0, negative 1, negative undefined, which is the same thing as negative infinity. And guess what? Let's take a look at this really quickly. Let's see what it actually looks like. Cotangent of x is quite literally like flipping our tangent of x. Oops, well, let me zoom in. Maybe. Let's see if I can. Oh, it won't let me touch any of them. There we go. And we can quite literally see that it's very similar. It's just shifted to the right, right? So now it actually starts, it goes from 0 to 2, not 2 pi, sorry, pi over 2. But a lot of teachers teach you as this part right here. So from negative pi to 0. They teach you that this is the first period. It doesn't really matter if you want to graph this one first, that's fine. But I'm going to teach it to you this way because this is how you normally learn. Just like tangent, we know it repeats forever, right? It's going to keep repeating. But we care about this as our like main one. We're going to care about this as our main one. And let's graph that. So that's going to look like we have negative pi. Oops. Sorry, let me move this to this side. Here is negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, and then 0. And we're going to graph our asymptotes like we would on our tangent graph. And we're going to label positive and negative 1. And we're just going to mark it. Here's positive 1, here's negative 1, here's 0. And it's the exact same shape as tangent. That's it. Let's do one example for cotangent, okay? And then we can stop for today. So, example, we're going to do cotangent of x minus pi over 6. All right, and we know that the period is pi. Why? Well, there's nothing in front of that. So the period is just pi over b, which is pi over 1. In this case, that's just pi. And that's the normal period of our cotangent graph. Then we're going to label x and y. But remember, we got to edit our table. X is x plus pi over 6. So, and then of course, let's label what is our asymptotes. Well, this is just going to be at negative period. And so this one's a little bit different. All right, we got to remember this. Well, actually, let's do it like this. Sorry. Let's take our, let me just label this pi. Let's fill in our table and see what we get. So this first one we know is usually negative pi. What happens when I add a pi over 6? What do I get? Negative what? So negative pi is the same thing as negative 6 pi over 6. What happens when I add pi over 6? What do I get?
Negative 5 pi over 6.
Yep, so the first part, negative 5 pi over 6. All right, and then the next point we know is negative 3 pi over 4. What happens when I add a pi over 6 to that? Can somebody do that really quickly? And you need to find a common denominator. So what's the common denominator between pi over 6 and negative 3 pi over 4? What do I got to make these the same? Well, they both share 12. We could do that. So that would be multiplying this guy by 3 and multiplying this guy by 2. And this gives me negative 7 pi over 12. So that's my next point. And we gotta start getting used to doing some fraction algebra. All right, well, negative pi over 2 plus pi over 6. Well, this one we could just multiply. That's negative 3 pi over 6. So this is 2 pi over 6, right? This is 2 pi over 6. Sorry, negative 2 pi over 6. And that's the same thing as negative pi over 12. And the last point is 0, which is just add pi over 6. That's pi over 6. And these down here follow the same. It's going to be positive infinity, 1, 0, negative. Oops, I wrote those too close together. 1, 0. Oh, wait, I'm missing a point. Let me move these over. These go here. I forgot to do pi over 2. That one is negative pi over 3. Why? Negative pi over 2, right? This is negative 3 pi over 6 plus pi over 6. That gives me negative 2 pi over 6, which is negative pi over 3. And then this one we already did. Sorry, that's pi over 4. So that's going to be negative 1, and this one's negative infinity. Does everyone understand? Can you give me a thumbs up if you understand how to set up this table? Helena, does that make sense?
Yeah.
Any questions? Okay. And then from here, all we do is we graph it. So we graph our x points, right? We have right here we have negative 5 pi over 6, negative 7 pi over 12, negative pi over 3. This one's negative pi over 12. And this last one is actually over here. It's pi over, let me draw this a little closer. It's actually pi over 6. And then we just label our asymptotes, which are these two. Oops, let me label that a lot better. And then we label all of our points. So we know it goes from +1 to -1. And right here, we're going to have +1. Right here, we're going to have 0. Right here, we're going to have -1. And that's it. We follow the asymptote. And this is how we graph each of our graphs. Any questions on each of these before we go? How we graph cosecant, how we graph sine. If you are confused, so let's take a quick look at let's do this very quickly. Let's take a look at our homework. Give me one sec. All right, let's take a quick look at our homework assignment just really quickly, if everyone can see this. So today we're going to be doing 4.5. And for this guy, that's going to be these guys right here. And we're just going to be doing, I think it's just 2, 3, yeah. It's all, most of the odd numbers. But we're going to be doing these ones. And remember, all we're going to do is we're going to follow those steps. So for cosecant and secant, we're going to first graph sine and cosine. And if you ever are having trouble remembering how to do this, take a look at so here's our notes. This is to help you remember what everything is for sine and cosine. Okay, it tells you your period. It tells you if you remember the shape, right? This is going to be our fourth interval. So that just means we remember multiply by 1/4. This is what each of the things mean. If you can get this down, then just remember for tangent, these are our notes for tangent. And cotangent is the exact same as tangent, but it's backwards. Okay? Does anyone have any questions before we go?
I just had a question. We still
Mhm.
have a lesson on Friday, right?
I believe so, but let me confirm that. I will tell you right now. Give me 2 seconds. I want to say we do. Yeah, we have one this Friday, and same thing next week and the week after, same schedule. Nothing changes.
Okay. Is it okay if I leave like a little bit before 6 on Friday?
Yeah, of course. And then yeah, just try to take a look at the video after. Alrighty, I will see you all on Friday then.
Bye, thank you.
Bye,
All
thank
right,
you.
awesome work, everyone.